Okay, question 21, and this is the question 21 after question 29. For some reason, there was a question 29 earlier. So it says a company has found that the demand for its product, the demand is going to be labeled as D. It varies inversely as the price of the product, and price is P. So asking us to write an equation relating demand D and price P. Now, back in the early part of the semester, we talk about direct relationship and inverse relationship. So I'm gonna give you two choices right here. We'll say, well, is it D times P equals to K? Or is it D over P equals to K? Which one is showing you inverse relationship? Okay, given that K is a constant, K is a constant that is not going to change. Which one is showing you the inverse relationship? Which one is showing you the direct relationship? Okay, so the answer is that the left one is the inverse relationship. The right one is the direct relationship. But why? Why? Okay, I think it's very important to know the why. Now, K, again, it's a number that's not going to change. So if D goes up, in order to maintain a constant on the right-hand side of the equation, well, P must go down. Okay, now in class, I showed you how to make sense out of the equation because the equation could be a bit abstract. So to make it less abstract, we can think about a number 100. So we can say, 1 times 100 is equal to 100. And then if I increase the first number from 1 to 2, what happened to the second number? Well, in order to maintain this constant on the right-hand side of the equation, the second number has to go down. 2 times 50. If I keep increasing the first number from 1 to 2 to 4, then the second number would go down from 100 down to 50 and go further down to 25. So this is a very good concrete example to show you why when two variables are multiplying together, it shows you that they are inversely related. Okay, so that would be our equation to begin. Okay, but we have to find out the K value. So K is equal to the demand, which is 600 units. And then the price is 3.75. So K is equal to, let me see what K is equal to. K is equal to 3.75 times 600. And that is $22.50 unit. Okay, not per unit, just times unit. This is the unit of K. It may or may not mean much to you or to us because, because it's dollar times unit, not per unit. It's not a division, they are multiplying together. So this is the K. So now that's not the equation yet. The equation is D times P equals to 22.50 times unit. Okay, that would be your equation. Okay, or any variation of this equation. You can divide the P, you can divide the D, depending on what you want to find. Okay, so a variation would be D is equal to 22.50 times unit over P. So so that would be a good model for you to think about, if I change the price from $3.75 to, let's say, $5, if I change it to $5 for the price, what would the demand be? So you can just substitute the price, $5 for the price. And you can actually do 222.50 divided by 5, and that would give you 450. So the demand would be 450 units. You can see the dollar sign would be canceled out if you put in $5 for the P value. Okay, so this is the equation. This would also be an acceptable equation. This would also be an acceptable equation. Okay, just make sure that the units are proper. Okay, don't say per unit when there's no division. It's just dollar times unit.